Okay, this now you guys, you have a test tomorrow, Tuesday, Wednesday. Wednesday is the partner test. The individual test is all set. Not easy. Does have some AP stuff on it. Yes, you have to know continuity. Okay, you may not use these rules for derivatives tomorrow unless you're told to. You have to use the definition. Okay, now if you think your way through this, it's a lot easier. Okay, Matt? What's the slope of a horizontal line? Because that's what y equals c is. 0. What's the slope of y equals x? 1. Now, what's this rule? Now, this is a power. This is not true for exponential functions. It's n x to the n minus 1. Do you remember that you can pull the constant out of there? So it's c times the derivative of f with respect to x. Because if you go look at the product rule, you'll see why that has to be that way. And you remember that you can distribute a derivative over a sum or difference. So it's f prime plus or minus g prime. So it's really tempting to say if I have a product, then I can do the same thing. And unfortunately, you can't. Now, do you remember what no chain rule? That's not yet. This is e to the x. Now, do you remember, like the phoenix rising out of the ashes, do you remember the derivative of a to the x? There you go. AX ln A. Shut up. Oh, because A to the X Lena. That's right. Because my first name is Lana. Lena. So it's Lana. Mm-hmm. So you can almost see my name there. That should help, I'm hoping. Okay. Let's use the definition. Yeah, I think everybody's here. Oh, no, he's not. At least I don't see him. Yeah. He's where? Okay. Do you guys know why the power rule, what it is? Okay, maybe a better question. Do you care? Hey, guys? Do you know why that's n x to the n minus 1? Hey, guys? Nick, do you know why this is what it is? David, do you know why it is what it is? Oh, it's because you got the n. Drew, do you know why it's n times x to the n minus 1? I was hoping you could tell me. Well, f of x, okay, Grant, is x to the n. And the definition of a derivative, because this is review for your test anyway, is f of x plus h minus f of x all over h. You see the slope there? Because what you're going to get on the exam is you're going to get a limit, and you're going to say, oh, it's the derivative of x cubed, which is really easy to do, rather than using the definition. That's what's going to happen on the exam. It'll be multiple choice. And you're going to have to recognize that that's a derivative. You also have to be able to do that on your test tomorrow. So let's do x to the n. This would be the limit, and I would almost would like to leave this open for you to try this. It's x plus h to the n, right? Place of x, you put in x plus h, and in x, you put in x, so it's x to the n all over h. And the only way I can think of to do that is to expand it. I have to use the binomial theorem. 2 times x plus h to the n plus x to the n. Pardon? What'd you say? I could, that won't do me any good. I have to actually expand it. So if we look at expansions of x plus h to the 0, that's 1, right? Okay, guys? Brant? X plus h to the first is 1 times x plus 1 times h. Remember Pascal's triangle? 1. Okay. Well, let's look a little further. Some people, Grant, might be interested. I would hope you're all interested. Okay, so I'm going to square that out, which is going to give me 1x squared plus 2xh plus h squared. That's this row right there. It is. Is that okay? Okay, that's all I did was FOIL it. But what do you do for x plus h cubed? Because the coefficients are 1, 2, 1. What are the next coefficients? 1, 3, 3, 1. We're just going to do enough to see a pattern. And you'd have to prove this probably, forgot what it's called, proof by induction. But right now we won't. We're just going to observe. Okay, Drew? This is going to be 1x to the third plus 3x to the second plus 3, oops, forgot the h's. Remember, these have to add up to 3, these exponents, so it's h to the first plus 3x to the first, h to the second, plus 1h cubed. Okay, Michael? Eric? Should we look at the next one?
Pascal's triangle x plus h to the fourth.
Well, okay. Okay, guys? Let's do one more. We're looking for patterns. What would x plus h to the fourth look like? No, h plus, so it's 1, 4, 6, 4, 1. That has to do with combinations or permutations. I forget which.
Dude, I want to do some Pascal research. I don't know. Triangle squared. That's Pascal's triangle. I don't know what the word is.
No, that could be a project to look at after our exam.
How does it work? I don't like this. I have no idea. To be honest, Pascal's triangle.
Well, you have to look it up, won't you?
Fibonacci sequence.
It is, I believe there's a relationship there, but I have to think about what it is. Okay, the coefficients are 1, 4, 6, 4, 1. Okay, guys, we're going to get to the hard part pretty quick here.
Is this going to be on like the testicle?
No, but don't you want to see why it's n, x to the n is n, x to the n minus 1? Okay, waiting. Okay? See what happens to exponents. They go down. There's also something else that's interesting here that maybe you didn't notice. That this number here and this number, okay, so let's do x plus h to the n. We don't have to go very far with this. It's going to be x to the what? N, okay, Sam? And Will? Plus, then this number was n. Then what's this one? X to the n minus 1 times h plus, I don't really know what that is. Actually, I do, but I don't really care. Some sort of number. Then it's going to be x to the n minus 2, h to the what? 2, right? Because the h's start going up, etc. And you'll be left with h to the what at the end? N. Okay, let's put that into our derivative formula. Okay, so f prime of x is equal to this, what I have here. You'll see why I don't care what that number is. It's actually n times n minus 1 over 2, I believe. X to the n minus 2, h squared, h to the fourth, and then we have to subtract, I forgot my limit. Not good. As h goes to 0, we have to subtract x to the n all over h. What happened? Not yet. What happens to x to the n's? They miraculously cancel. And so you have the limit as h goes to 0 of n x to the n minus 1 times h plus n minus 1 times 2 x to the n minus 2 h squared h to the fourth. It's all over h. I just know what it is. Think of it just as a number. It isn't going to matter what it is, even if I do it wrong. I could be doing it wrong, but I'm pretty sure that's what it is. Now, when I divide the h's, you guys, what happens when you divide the h's? This will go into this. So there's no h's left in this term, right? I'm going to divide h into every term because you have to do that. Then I'll be left with an h here, right? And I'll be left with an h squared next one, and this will be, that should be n. I'll be left with h to the n minus 1. And then when h goes to 0, what happens to all of these? Therefore, they're all 0. Notice I don't care what that number is. I could figure it out. I don't really care because it's still going to have an h in it, and it's going to go to 0, and my resulting answer is this. Now, I think it's kind of cool to have seen it. Do I expect you to be able to do it? No. Because I observed some patterns here. Yeah, but that h goes away in this one. No, I'm dividing by h first because this is my whole h over h. 0 over 0 is always my whole. It's a limit, remember? Okay. Then I'm still left with an h here because there were 2 h's and only one canceled out. And what happens to all these h's? They keep going up in number. Now, this is what you do, guys, with a math major. Just to let you know, this is part of what you do as a math major. Except they'll talk about null sets and kernels, and those are words you've never even heard of. Yeah, don't you wish? Okay, why did I use n? Because look what happened. Shh. You guys, on the term right here, look at the exponent and this one. Now, this is not proof, but I'm doing this by observation. Deductive or inductive reasoning?
Deductive.
I think it's deductive, isn't it?
Inductive is in the bacon.
So these numbers are the same, so guess what? It's n times x to the n minus 1. It's just kind of cool to see it. Now, that requires the binomial theorem. We haven't done that, so that's part of the problem. Okay. I just think that's kind of neat to see that. Now, what about a to the x? Using the definition of a derivative. I don't know. It's the limit as h goes to 0 of, well, it's a to the x plus h minus a to the x all over h. And in second quarter, we're going to have to deal with exponents more. So we have to know how to do this. No, it's a to the x times a to the h. Do you agree that is equal to a to the x plus h? Let me say it again. If I have the same base, x to the m times x to the n, that's x to the m plus n. We're going to do a lot of this next quarter. If I reverse it, which is what I have, I end up getting that. This goes both ways. That's a definition. Minus a to the x all over h. Now, what can I factor out of there? A to the x. So it's the limit as h goes to 0 of a to the x, and I'm left with a to the h minus 1 over h. Now, does h apply to the a to the x? Does h affect a to the x? No. So it's times the limit as h goes to 0 of a to the h minus 1 over h. So what does this mean? The rate of change of any exponential function is proportional to a to the x. So in other words, any exponential function, its derivative is proportional to the same back again. You know what this number is going to be, but we could put it on our graphing calculator and see. It's going to take a little bit of work.
Dude, I'm like all my classes use my calculator now. Because every time I go to AP Physics, I have to change it from radians
Oh, that's
to
a problem, yeah.
degrees. And I'm like,
A to the x. Now, that's the activity. Do you guys know what that is? That's the log of A, isn't it? Oh, well, we could try it because that's what the next thing is. Okay, here it is. The derivative with respect to x of 2 to the x is going to be, if I use the limit definition, it's going to be 2 to the x plus h minus 2 to the x over h, which is the limit as h goes to 0. And I'm going to have 2 to the x times 2 to the h minus 2 to the x all over h. And I'm going to factor out 2 to the x. I'm going to write it up here because I don't have any room. So it's 2 to the x, and it's 2 to the h minus 1 over h. So should we look at that value on our calculator? Why not? Well, I'm claiming it's the log of 2. Is it? Oh, wait a minute. I'm a product of the 60s, as I told my AV classes. You got to question everything. You should be always questioning everything. Parents will kill me for saying that, but okay. So let's take a look at that. Mm-hmm. Yeah. Okay, I want to graph this 2 to the h minus 1. I'm going to do 2 to the x minus 1 over x and let x go to 0. It's easy. So parentheses, I could make it h, but you know my graph is x. So I'm going to make it x. They're dummy variables. Whoops. Try that again. It's 2 to the h, 2 to the x. Where's my caret? X minus 1. I mean, aren't you curious? Is it really the log of 2? Okay, I'm curious. I haven't done this for a while. And now, do you want to graph it or do you just want to look at the table? I want x to get close to 0. I like the table myself. This table set, we're going to start at 0, and we want to be really close to 0. So I want point. Now, do you guys know what the value of log of 2 is? Probably not. 0.69 something. Okay, we're going to go second table. And if I go over and down, I'll get a better estimate. So I get 0.69. That's what I get using my calculator. Let's find the log of 2. That is this limit right here. This is the limit of this. Then I have to do times 2 to the x. Okay, but let's see what log of 2 is. Log of 2. Let's see how close we are. That's the log of 2. Oh, come on, you guys. 474. That we're off here.
That's not L. That's ln.
Of 2. Oh, that's log.
Log is ln.
Natural log. We don't care about other bases.
No, ln is log e. I know.
Yes, because the derivative of this is going to be 2 to the x times the log of 2. I don't know why I want to use, how I could use n derive on my calculator. I can on my CAS. So if I bring the CAS up, I can.
Wait, so it's not log of 2?
It's 2 to the x times the log of 2. So if you let x equals 0, I should get what? If I took the derivative at 0, so what's the derivative at x equals 0? It's what? It's 2 to the 0 times the log of 2, which is log of 2. So let's look at our calculator and see if that's right. You're so trusting. Okay, so I'm going to do math. You remember how to do this? H, n derive. I want 2 to the x comma x, where's x, comma 0. Now, if I got my CAS out, I'd have it exactly. I should see the log of 2 there. Looks like the log of 2 to me. Where's this one? 0.61318.
Oh my god.
You know, it's doing it numerically. So you could experiment with 3 to the x. No, that's right. No, it's ln of 2. You're doing wrong base. Okay. I think that's it. Oh, yes. Okay, you guys, is the test tomorrow hard? Yeah, it is. If you haven't done the homework, you're going to find it hard. Okay, guys, you have to know that one. The definition of E, guys, is the number such that the limit of e to the h minus 1 over h is equal to 1. What is this the derivative of? E to the x. At where? At 0. Here, see, because this is e to the h plus 0. So this is e to the 0. This is why you look at this and you say, oh, that's e to the x. And the derivative of e to the x is e to the x at x equals 0, which is just 1. It's h plus 0 because the c is 0. Because what if I want the derivative of e to the x? It's e to the x plus h minus e to the x all over h. And we're going to let x be 0. Then I get that. Otherwise, if you do this, it's the limit as h goes to 0. It's e to the x times e to the h minus 1. Pull that out. That has to be 1. Well, it's always 0 over 0, unfortunately. Okay, if s is the position of a particle, because this is in the section 2, what's the velocity? Remember? ds d what? T. What's the acceleration, Grant?
The acceleration is a of c.
It's dv dt, or the second derivative of the position. That's what it is. Vector. Okay, well, that's 3-1. Well, guess what 3-2 is? Product and quotient rules. Can you guys look that up, or do you want me just to quickly do it?
Oh, I already know it.
Tomorrow you have a test. You want a time.
Low dehydrogenate low over.
Right.
Is that right? Low squared on the bottom?
Yes. Now, David, you haven't taken this quiz, homework quiz, right? Yeah. Who else hasn't taken the homework quiz? You could go take it right now. Up in the resource room, 2611.